Hello and welcome back to Azure Terraformer. Last episode we were exploring a Linux virtual machine in the Azure Portal and seeing what we got by default using the Azure Terraform resource. And then also seeing like what we could automate beyond the defaults out of the box. And so today we're gonna continue that journey, and we're gonna go look in the portal and see what else we can do. Here's my virtual machine that I provisioned, and you can see down here I've got boot diagnostics. This is what we configured last time, and what I'm going to go look at is my diagnostic settings. And here my diagnostic settings, you see this wizard in the portal, and it wants me to next click to deploy. Which I can do that, and this is a good way to kind of explore and figure out how you're going to automate something. I mean, you have to, in order to automate something, you have to have manually done it at least one time to see how it's done manually, and then you can automate it. So don't feel like you have to be allergic to the portal when you're working with Terraform or with infrastructure as code. So I smashed that next button. And we're just going to see what it does. It looks like we got a failure deploying the virtual machine extension. Let's go check out why. Enable failed. So let's uninstall it and let's see what's going on here. Now the version of my virtual machine is 2023.04.4, and I built this Packer image on my Ubuntu 2004 baseline. So if I go look at my pipelines, and let me go find where this Ubuntu image is being built. And so this is it. So we got 2023.04.04. So if we go look at the source code that produced this image, we can see that we added Python 2, and we're running some scripts to configure Python 2. The diagnostic setting for Linux virtual machines requires Python 2. So there is a Python requirement, and basically I added this to my Packer image to ensure that the virtual machine has the prerequisites needed to run the Azure Diagnostics virtual machine extension. But it doesn't explain why the virtual machine extension failed. Maybe that was a transient error. So that old saying, the definition of insanity is trying the same thing twice and expecting different outcomes. That's not always the case. So literally, I made no changes. I just had a little transient error, and provisioning succeeded this time. Extension daemon started. Now let's go interrogate what happened. We can go look at the virtual machine's activity log, and we can see the deployments that took place. So here we can see that the virtual machine extension failed, and then we can see the successful attempt. And in the JSON, we have a lot of details about what happened. But if we really want to see what the deployment was, then we should go to the resource group. So if we go out to the resource group, we can go to the deployments, and we can see the deployments that happened. And so this can give us a lot of really good detail because it gives us an Azure resource management template that shows what we're provisioning. And you can see here we're provisioning a single resource of type virtual machine extension, and this is the name, and we've got the publisher, which is Microsoft.Azure.Diagnostics, and a type of Linux Diagnostic, and a version number of 4.0. And then we see some protected settings, We're getting the storage account name, which is what we selected in the UI. We're generating a SAS token. You didn't have to do this in the UI. The GUI wizard kind of magically makes this happen for you, using your credentials that you're logged in with interactively. And then we have the settings block. So all Azure Linux or all Azure virtual machine extensions follow the same pattern. We have a protected settings, which is typically where secrets or sensitive data goes, and then which will not be returned on future requests. And then you've got this settings block, which contains all the other config. Now, many of the older versions of the Azure Monitor Diagnostics were very similar. I think the log analytics extension had a very similar fashion where you'd put in a log analytics workspace ID and then like a workspace key, and the key would be in the protected settings, and then the workspace ID would be in the settings. Here we see just a storage account being used, and then we have this huge block of JSON. I mean, what did we start on here? We started on line 32, and wow, like we have 700 some lines of JSON in here. And basically what this looks like is we just have a bunch of performance metrics that, like built-in performance metrics that the portal just magically knows. Like somewhere down deep within the recesses of Azure, this wizard will generate this ARM template based on you using a Linux virtual machine, and it knows that these are the metrics that it should pull. Is that fair? Would it be nice if there was documentation out there? And maybe there is documentation, out there somewhere. But this is a really effective way to figure out what exactly these helpful wizards, GUIs, do within the Azure portal. However, if you want to avoid having to click to deploy, you're going to have to figure out what those GUIs are doing so that you can automate it. And that's what we're going to do. So what I've done, I have taken this JSON from the settings, and I've extracted that into my Terraform modules library. And we're going to go look at that right now. Here in my Terraform modules library, I dumped the JSON into this file, and you can see it's about 700 lines. I got rid of everything except for the settings payload. And so you can see the JSON that creates this. We have metrics, we have performance counters, which there's a boatload of. I think performance counters go from 17 to 673, right? And then we have syslog events, which there's not too many of those. Relatively small. And then we have a sample rate in seconds. So this is basically an object structure that's defined using JSON. And we have a storage account name at top. And so you can see I've put in a template parameter here. So if I wanted to, I could use this file and I could import the contents of this and pass in a parameter using template file to load in the contents of this file. That's one approach that I could use. Another approach is I could actually convert this JSON object into HCL. Which would make it a little bit more concise, but I have to replicate the object structure in HCL, and then encode it into JSON. So it's kind of like I'm converting the JSON into HCL, and then I'm using the JSON encode function to convert it back into JSON because that's what Azure wants. So it's a little funny, but I've done that ahead of time. Spoiler alert. Here's what that looks like. So when you look at, and I can open the JSON to the side and we can just look at it. So you can see we have the storage account here and the storage account here. Now, when you convert JSON into HCL, HCL doesn't require you to have object object attributes with double quotes. So you can just remove that. You probably want to maintain the case sensitivity, because if the JSON schema wants capital S, capital A, you probably want to leave it like that. You don't have to use a colon anymore. You're going to use an equal. And now one of the benefits of using this approach is you have a much cleaner syntax of leveraging other resources or variables within Terraform code within this object structure. So you don't have to use string manipulation to insert values from Terraform. It's literally just like defining an object in Terraform, and this is a local object. And so when you define a complex object in Terraform, we set the object. So this is an attribute called lad config, and this is a complex object. We're implying that by this equal and then the open curly. So basically, we're defining a dynamic type. That dynamic type has an attribute called Diagnostic Monitor Configuration, which is also a complex object, which we've defined with the equal curly. And then that has some primitive attributes, which event volume is a string. We've got another complex type, more complex types. The list goes on. And so basically, it's a relatively simple process of mapping JSON into HCL. You just need to know what you have to convert. The colon goes away, double quotes go away, but largely map syntax, array syntax, string syntax are pretty much the same. So it's a pretty easy one-for-one conversion process. And so basically in my code here, I have this object that's declared locally. I could just copy this and save this, move this into a local object. And that might make more sense. Might clean it up a bit so you can see what I'm doing here. I'm just going to move this into a locals, and then I'm going to say settings payload. And literally it's just an object. It's an HCL object. It's a really big HCL object. But it's literally just an object. And so I've got the settings payload, and in my JSON encode method, I can just say local.json payload, and it's just like any other object. JSON encode takes an object and converts it into a JSON encoded string, which is what Azure ARM requires when we're creating a virtual machine extension on the settings and on the protected settings. So you can see here, when the object's really, really small, this is very useful because then you can look at HCL code and it's very concise, and you don't have all the JSON craziness happening, and you can reference variables in a pretty easy way, and we can use functions, and we can do cool things without doing a lot of string interpolation and worrying about, do I need to escape this, or do I need to escape that? How do I handle double quotes? How do I handle single quotes? Yeah. All that stuff gets pretty simplified when you just declare it as an HCL object and then use JSON encode, and then you're happy. So basically, I took this 700 lines of JSON, I converted it into HCL to demonstrate this principle to you. And I'll post this onto my GitHub repo as well. But this module, I published this module, git tags. I think we're at version 1.09. And so if I want to attach this virtual machine extension to my virtual machine, I just need to reference this module, version 1.09. Now, I should be careful and look at what the contract is for this module. So this module needs, like any virtual machine extension, it needs a virtual machine ID. Because it is using the Linux Diagnostic, let me get rid of this JSON. Because we're using the Linux Diagnostic virtual machine extension, that requires a storage account name right there and a SAS token. And these need to be passed in to this module. I threw on a storage account key because I was experimenting with that as an option, but I think a SAS token is the right way to do it. I have not confirmed whether a storage account key is even a viable option, but all the documentation says a SAS token. So I made these two mutually exclusive. Of course, I'm not even using the storage account key. If you look at my code, basically I'm assuming you pass in a SAS token. So another thing about the SAS token is when you generate a SAS token using Terraform, it's going to have a question mark in front of it. Question mark SV equals blah, blah, blah. And so here I'm just kind of trimming that prefix off there, getting rid of any question marks on there, because this protected settings block is not expecting that question mark there. And you will get an error trying to authenticate with Azure Storage. The virtual machine extension will fail trying to authenticate with Azure Storage if that question mark is there. So it's a very important little setting there. Now let's go update my module let's go update my virtual machine to use this module to add this virtual machine extension instead of manually deploying it through the portal. So first of all, let's go clean up what we've done in the portal. I'm going to delete this VM just so that we start clean. Okay, it's gone. Wonderful. I'm going to just rerun apply to bring back the VM. I deleted it just to clear out anything happening locally on that VM just in case. But I want to bring it back now so I can add the virtual machine extension to it. So while that's going, I'm going to declare a module, and I'm going to call it Linux Diag. And Linux Diag is going to have a source of a very long URL. The path of this module is not a virtual machine, it's a virtual machine extension. And the name of the extension is Linux Diagnostic. I need to specify a name. So I'm just going to say virtual machine extension, diag, and then module. I'll reference the Linux VM hostname. Okay, because this diagnostic, this virtual machine extension is inherently tied to this virtual machine, as we will see here. Virtual machine ID is equal to Linux VM.id. And now here's where it's going to get interesting. Storage account name is equal to data.azure storage account. And we're just going to use the boot diagnostic storage. The boot diagnostic storage is the same storage that we use for our observability stack. And we're going to get its name. Okay, now here's where it gets fun. So we need a storage account SAS token. And so this is going to require us to use a new resource. So let me go look up this resource. So we've got this storage account SAS token here, and we have a sample here. So let me go grab this sample. Now I need to reference the storage account connection string. So I'm going to grab my boot diagnostics and I'm going to jam that onto the front. And we're going to use the primary connection string there. HTTPS only true, that's good. Service is set to false. According to the documentation, I need container access and I need object access. Ooh, false. I also need blob and table access. And from a permission standpoint, I need exactly this. So we're going to use this here. Now, here's something interesting that I can do with my expiration token. So I'm going to also use, instead of using hard-coded times, I'm going to use the Terraform time provider. So I'm going to declare a new resource, and it's going to be called time offset, and it's the SAS expiry. That's what I'll call it. And we're going to say offset years is 1. And then I'm going to say resource time offset SAS start. And we'll say offset days equals -1. So basically, we want the SAS token to start yesterday, be effective yesterday, and we want it to expire 1 year from today. Time offset start, and we need to use the RFC 3339. Yeah. And so we'll do the same thing for the time offset expiry. There we go. So there we go. I think we should be good with this. So I've set up a SAS token. I already have my storage account name, and I'm basically, this module is encapsulating that big nasty JSON, like with all the performance counters and all that stuff on it. And it's going to attach that diagnostic setting. Now let me go check my apply. Okay, so we added the VM back just to prove. Let's go back out to the portal and let's check out Mr. VM to make sure he does not. We still see that GUI wizard, so the diagnostic setting is not set up. Okay, so if the diagnostic setting's not there, Azure Portal is like, hey, do you want to add it, newbie? You know, and we're like, no, we want to run our own Terraform code. So let me. I think we're good to go. Let's reapply this. So I'm going to run Terraform init, and we're going to pull that new module. And then let's run apply. And we should see a few new things get created. And we are. 3 things to be exact. Probably the SAS token. Probably the... There should be more than 3, right? Because we have those time things. So we've got the virtual machine extension, the SAS start, the SAS expiry, and then the SAS token itself. That's interesting. So I think that would count as 4 things. Strange. Oh well. But that looks good. So the time provider is super fast. It happens in memory. Many of the utility providers are in-memory providers that offer some kind of, it's almost like a base class library, if you will. They provide different APIs, SDKs that you can use to make your life easier. They don't actually talk to an API like the AWS or the Azure Terraform providers. They're completely dependent on this external API in order to get information and to post information to it. But a lot of these utility providers are just, all local, no external dependencies. So now we're creating that diagnostic setting or virtual machine extension that will enable the diagnostic setting, and let's see what happens. Okay, so it's done. Let's hit the portal and let's go smash the refresh on this page. And instead of seeing the GUI, the newbie GUI, the click to deploy GUI, whatever you want to call it, we see our diagnostic setting. And this is a pretty accurate representation of what we see in that big JSON blob, right? So we could go manually manipulate this, and guess what that's going to do? It's just going to update the settings of the virtual machine extension, and probably re-provision it, run an update, right? So let's go look at our virtual machine extensions. So they're under extensions, And we can see we have one. It's got that naming convention that I used. It's called, so again, the name of the virtual machine extension really doesn't matter anything. You can make up whatever you want. But the type and the publisher and then the version are extremely important. And provisioning succeeded. That's a good sign. But that's not, you should probably, don't always trust that. You always want to go look at the status message and see if there's any errors in there. Because sometimes the virtual machine extensions can be a little sneaky. Sometimes they say, oh, successfully installed. But then you go look at the status message and it's just like a Christmas tree, like red flags, yellow flags everywhere. So it's always good to go check the status message inside the virtual machine extension to see what happened. So now that we've set up the virtual machine extension in the diagnostic setting, let's go look for the logs. I'm going to go to my storage account that I've used, and I'm going to go look at my tables. And you can see here I do have a Windows Azure Diagnostic metrics table and a Linux syslog table. And I can go browse data in those tables by going here. So if I go look at my syslog, I can see that there are records that are pretty recent. Daemon, etc. And if I go look at my metrics, I can see that metrics are coming through here as well. Awesome. Now, there is one thing that I am forgetting. If we go look at the documentation, we can see that in order to use the Azure Monitor Sync, we need a couple of additional things. Particularly when you have the Azure Monitor Sync enabled, VMs need to have the system assigned ID set up so that they can generate the tokens that they need in order to communicate with Azure Monitor. Now, to do that, we need to make some changes to my Linux virtual machine module. And then we'll also have to go and update my my virtual machine extension module to include the Azure Monitor Sync. So let's go look at what we do there. And we can see this in the documentation too. So basically, we need like a syncs config block and the AZ mon sync, and this should be in the settings, not the protected settings. And if we go look at the sample documentation that they have, if we want to set up additional syncs, i.e., right now my Azure Monitor, my diagnostic metrics are going to Azure Table Storage. If I want them also to go to Blob, then I need to set up a JSON Blob sync. And so maybe what I should do is set up a syslog JSON Blob sync and set up a metrics blob, JSON Blob sync. And now those need to be declared in a syncs config in your protected settings. But then you also need to reference them in the syncs, on the syncs attribute for the syslog events, and then also the performance counters. You've got a syncs here. So if you wanted to do something like Event Hub and pipe these events through an Event Hub, you'd have to add that sync manually. So just to demonstrate that and get that going to blob storage, I'm gonna go and set that up in my in my virtual machine extension module so that we can see how that works. So first of all, let me go let me go uninstall the virtual machine extension, because we're gonna add a new version of this, and I just want to get that queued up while it's doing that. Let me go look at my module. So in the virtual machine, I'm gonna need this block right here. Identity. So on the virtual machine resource, Linux virtual machine, just at the bottom here, I added this identity block. I set the type equal to system assigned. You can set this either to system assigned and user assigned, or just user assigned. And if you have user assigned in here at all, which it just gets added, to this string. I can't remember if it's comma delimited or space delimited. It feels a little hacky doing that, but that's the way it's supposed to work. If user assigned is in here, then there's another property that applies, which contains an array of managed identity IDs. But for what we're doing, all I need is system assigned. I'll probably expand this module to allow additional managed identities to be passed in here, and then intelligently add user assigned or not. But for right now, I just need system assigned. Let's go look at the virtual machine extension and see what we need there. So now here we've got a couple of things going on here. So if you remember, I have the settings payload, and previously it started with the storage account, but now I need to add this syncs config block, which adds my AZ monitor sync in here, okay? Which this sync requires the managed identity to be set up on the virtual machine, the system assigned managed ID. Now, I'm also going to, in my protected settings block, add a syslog JSON blob to pipe the syslogs to blob storage. And then I'm also going to add a sync. I'm just calling it my JSON metrics blob, which the type is a JSON blob sync. And it's going to send the Azure Monitor metrics to blob in JSON format. So these are declared in a syncs config that's stored in the protected settings, but if you recall, they need to be referenced in a syncs block in my my actual virtual machine extension settings. So syslog events, it has a syncs attribute. This, I think we saw in the documentation, could be a comma delimited list where I could have event hubs in here. I could have blob syncs in here. I could have whatever syncs I want, whatever syncs are supported. You got to declare your syncs in your protected settings and then reference the syncs and add them as listeners to the particular events that you want to use. So I've gone ahead and I pushed a new version of this module. It's version 11. So what I'm going to do is I'm going to go back to my code, and I'm going to reference, instead of version 9 of the virtual machine extension, I'm going to reference version 11. That's going to bring in the syncs, and then let that sink in. And then I'm going to reference version 11 of my virtual machine, which that is going to bring in that system assigned managed ID. And so now what I'm going to do is I'm going to run Terraform init to suck down those new versions of of those modules. And then I'm going to run apply and see what it wants to do. And so you can see here, we are modifying the virtual machine extension. We're adding this block of system assigned type, system assigned ID, and we are updating with our syncs config. And this virtual machine extension is just completely new, right? And it's that big mega 700 lines of JSON that goes in there. So I think we're good. Okay, so we've just reprovisioned. Let's go out and let's refresh. And there's my virtual machine extension, no errors. Let's go look at the diagnostic settings. This always concerns me. I don't know why. Usually save should only be active if there's something dirty on the slice, which I haven't changed anything, so it really shouldn't be. But it just feels a little funny. Notice we have Azure Monitor enabled. So this is that's something new that we enabled using the managed ID and the Azure Monitor sync. And so now let me just go log in using Bastion and activate some stuff. Okay, so I did some stuff. Now let's go look at our storage account and let's go browse our data and see if we can find anything. So if I already looked at the tables, now I'm going to look at my containers. So as you can see here, I do have a syslog folder in my a syslog container, and I have my JSON metrics blob container. So let's go look at syslog. Nothing in there yet. Let's go look at metrics. Nothing in there yet. Might just be like a delay. And let's go check the extension. Looks healthy. Let's check the diagnostic setting. Looks healthy. Still looks a little dirty. Not quite sure why. All right, let's go check out our storage account, and let's go check out the containers. So we've got so now we got something in our syslog, and we're navigating down resource groups. This is the resource group that our VM is in. It is the Microsoft.compute provider because it's a virtual machine. This is our VM. We're going all the way down, and here is our file. So let's go hit edit. Usually you can edit it, but okay. I just downloaded the JSON, and so there we go. We have some stuff in here. So clearly we are connected to blob storage now. So let me close this down. Let's go look at our metrics. And notice the structure is a little bit different. We got a metric name, and we average disk queue length, and there's some values in here. So there you go. So basically, what we did today is we took another step on our journey of configuring all the things of our Linux virtual machine using Terraform. This time we kind of expanded on what we did with the boot diagnostics, but with the virtual machine extension, and a pretty complex one at that. Where there's a huge payload. We have to generate a storage account SAS token, and pipe in some protected settings, and then a huge payload of JSON that we use the JSON encode method. We looked at how to use the time provider to use a time offset resource to create time out into the future, and so that we can re-update that every time we run Terraform apply. So got a lot of stuff done, and hope you enjoyed this video. Hope you find it useful. Hope you see this as a great way to encapsulate observability into your virtual machine module, which will be expanding here very soon, to make our virtual machine module better and better, right? Also, don't forget, I had to update the Packer template to install Python 2, which this virtual machine extension required Python 2. So it's always really important to check what virtual machine extension you're trying to install, what the publisher is, what the type is, what the protected settings and what the settings are, but also read the manual of that extension to see if it has any additional requirements. So hope you liked this video. If you did, please smash that like button. If you are enjoying the channel, or if you're new to the channel, please hit that subscribe button and ring that bell so you know when my next video drops. Got a lot more content coming, all about Azure, Terraform, automation, and best practices and cloud architecture and all that stuff. So please come back. Please subscribe. Really helps the channel. And until next time, this is the Azure Terraformer signing off.